We are going to do number 3. We're looking at number 3. Okay, so number 3, the first thing you want to do is factor, if you can factor. The numerator is a difference of 2 squares, so I'm going to factor into a pair of conjugates. And you have x plus 3 that can reduce out. So all you're left with is x minus 3 for your graph. Okay, so you're going to have a whole where x equals negative 3. So take the denominator that factored out, set it equal to 0, and that's where the hole is. So that means that you're not going to have a vertical asymptote because it reduced out. All you're going to have left is this line, y equals x minus 3. That's the only part of the graph that's left.
So you won't make it a vertical asymptote?
We'll still have a horizontal one, right?
No,
It won't have a horizontal one either because the degree in the numerator was bigger than the degree in the denominator.
Right. I didn't know if we wanted to use the second.
Well, the thing is, what happens, since it reduced out and this is all you have left, this line is actually your slant asymptote that you would have had. So that's how it works out. Anyway, so let's graph this.
So that is just a facing graph.
Yeah, it's just a line with a hole in it. That's right. So it's going to cross the y-axis at negative 3. It has a slope of 1. I want my graph to go over to where x is negative 3, so I'm going to make it go down a little bit. And then I want to find where on the x-axis x is negative 3 and go down to the graph, and that's where you're going to put the hole. I go on the x-axis to negative 3, and then wherever your graph is, when x is negative 3, that's where I'm going to put the hole. Okay. Any questions? So we're not going to worry about domain and range right now. We're just graphing and putting the asymptotes in the holes. So if they were asking you vertical asymptotes, you'd say none.
No.
Horizontal asymptotes, there are none.
but
It's not applicable.
so how does it go
It reduces out. So when this...
Is the vertical the denominator? So if there's no denominator, it's not.
Right.
Okay.
Okay. All right. This is one that is not on your paper, so you need to add it on. You can use one of the graphs that are not being used to graph it. Okay, so I want to factor if I can factor. Can that numerator factor?
Oh, yeah.
Okay. X plus 2 times x plus 2, right.
Yeah, or
So can anything be reduced out?
no.
No. So it's not going to matter.
No holes.
And there's no holes.
No hole.
Okay, so we could write that part down. Now the vertical asymptote, I'm going to take the denominator, set it equal to 0, solve for x. So I will have a vertical asymptote where x equals 1/2. Also, the numerator degree is 1 more than the denominator degree. So I'm going to have an oblique or slant asymptote. So I'm going to divide into, take the denominator, divide into the numerator. Okay, and that's going to tell me what the slant asymptote is. So you could use synthetic division on this if you want to. I'm just going to use long division. 2x goes into 1x squared, 1/2 x times. I'm going to multiply that back through. So 1/2 times 2 is 1. X times x is x squared. 1/2 times negative 1 is minus 1/2. And then x. And I'm going to subtract that from the line above it. So the x's are gone. This is actually going to be 9 over 2 because minus and a minus make that plus. Then I'm going to bring my next number down. Okay, so I want to divide 2x goes into 9 over 2x. So what happens whenever you have a fraction and you're dividing by a number, remember you flip the second number and multiply them together. So 9 over 2 divided by 2 is actually going to be 9 over 4. And you can multiply that back through, so that'll be 9 over 2x minus 9 over 4, and subtract. And you do have this remainder of 25 over 4, but it's not going to affect the line. You already have your line. You have your slope and your constant. That's your slanted line. So we don't really need the remainder. Okay, it's not important. This is your slant or oblique asymptote. So let's graph the vertical asymptote, the slant asymptote, I'm going to make my increments kind of big because of that x equals 1/2 asymptote. So here's my vertical asymptote and my slant asymptote. The intercept is at 2.5, and then have a slope of 1 over 2. So that's kind of like this. Okay, so to get your shape, you can type in the original problem to your calculator. And don't leave before I give you your assignment. And you can look at your graph there.
That does look like your y equals. Alright. More.